Hi everyone, welcome to the second video of the Introduction to Deep Learning course. So last time we understood what is learning and we had a historical perspective of how the current paradigm of machine learning developed. Now in today's video the goal is to understand what is meant by the word depth or deep in the acronym deep learning. So why do we need depth? So let's take a very simple toy example. Let's say we have two variables, x1 and x2, and we have a function that we call f1, and we will represent each by a circle because this is the notation that we will use for neurons in a neural network. But for now, let's say these are just two variables. And then I have a function f1 that's a linear function of x1 and x2, and then f2 is another linear function of f1. So imagine this is to represent a neural network where in each layer you have neurons that are linear functions of their inputs from the previous layer. So f1 is a function of x1 and x2, and this function is represented by a weight w11 times x1 plus another weight w12 times x2 plus a bias b1. f2 is a linear function of f1. So f2 is represented by a weight variable w2 times f1 plus a bias term b2. Now we can rewrite f2 as, so if we decompose f1 in terms of x1 and x2, then f2 as a function of x1 and x2 equals w2 w11 x1 plus w2 w12 x2 plus w2 b1 plus b2. Now I can take the term w2 w11 and that will be the weight for x1 in the function f2. I can take the term w2 w12 and that will be the weight w22 in the function f2. I can take the term w2 b1 plus b2 and that will be the new bias b2 tilde. Right? So we end up by having f2 is also a linear function of x1 and x2. Right? So I could have written, so instead of doing this, so here f1, I will denote w11 the weight on the link between x1 and f1, and w12 the weight, the link between x2 and f1, and w2 the link between f1 and f2. Now I could have replaced this by just a single layer network where I have x1 and I have x2 and then I have f2 here and I have here this new term w21 and I have this new term w22 and the new bias b2 tilde equal w2 b1 plus b2. So this is really a single layer network, not a two layer network. Right? So as long as we are using linear functions, depth is not needed. So actually the question of whether we need depth or no is related to the question of whether we need nonlinear functions or no. Right? So let's consider a simple classification problem where you have x1 and x2, again two variables, and then the points marked by the crosses here, these are belonging to class 1, so these points belong to class 1, these points belong to class 1, and then the points in the middle belong to class 2. Now you have to have a nonlinear discriminator to discriminate successfully between these two classes. Hence, sometimes in learning, and in this example for classification, sometimes we need to have nonlinear decision boundaries or nonlinear classifiers, right? So another word for a discriminator is a decision boundary. Right? So this is why depth can be useful, because we need nonlinear discriminators, and when we have nonlinear discriminators, it's no longer the case that a two-layer network is equivalent to a single-layer network. It's not necessarily the case. It might be, but that would be a special example. Sounds good? Now to conclude this video, let's understand the structure of a typical deep learning algorithm. So in the rest of the course, we will mostly take the example of a supervised deep classifier. Supervised mean that the input consists of example vectors as well as labels. So this is called supervised learning. And classifier means that it's a classification problem. So the inputs belong to different categories, and we want the algorithm to tell which category does the input belong to. So the reason is that this will just simplify our explanation, but most of the arguments we will make and most of the insights will also apply to regression problems, not just classification, and will also apply to unsupervised learning problems, not just supervised learning problems. So what does a typical supervised deep classification algorithm consist of? You have the input, which is the example vectors, plus the labels, and you have the cost, which is a function that guides the algorithm towards predicting the right labels. So basically, it's a function that defines a penalty between the predicted and provided labels. So it's some kind of a distance metric, right? So if the predicted label is different from the provided label, this function quantifies how much penalty you should take as a hit due to this difference. And then training, which is an algorithm that selects the network parameters such that the expected cost is minimized. Now let's take this this statement and analyze it further, right? So first it selects network parameters. What do we mean by network parameters? We mean the weights and biases in this example. For example, here the W11, the W12, and the W2, and the B1 and the B2. Right? Or in this example, it's the W21, the W22, and the B2 tilde, right? So these are, we call them the network parameters. So the training algorithm sets the values of these network parameters such that the expected cost is minimized. Now, why did we call it expected instead of just saying the cost is minimized? Because the training and testing data are typically different. So based on the training cost that we see, we are expecting a testing cost. And that's the real objective, is that the testing cost is minimized, not necessarily the training cost. Thank you.